Okay, in this class we discuss about the omitted measurements. First, understand what is the meaning of omitted measurements. In generally, these are conducted in the while conducting the closed traverse. If any circumstances it is not possible to measure all the measurements in the field. Maybe it will be obstacle due to any trees or any building. It is not possible to measure the directions of that line or distance between that line. Okay. In that condition, by observing the remaining data, by using the latitude and departure, we can find out the whatever the missing quantities in the field. These missing quantities missing measurements is called as a omitted measurements. Okay, simple. Omitted measurements what it is when it is not possible to take all the measurements due to any obstacle. Okay, these missing quantities or measurements are called as a omitted measurements. As I told that here for finding up with respect to missing quantities by using a latitude and departure. Already you know that in the closed traverse, whatever the total latitude and total departure is exactly equal to the 0, then you have to come to know that there is no closing error is there. So here we are considering the summation of L is equal to L1 cos theta 1 for the first line. This is second line. This one is third line. That is equal to 0. Similarly, summation of D or summation of departure, you will get always it is equal to 0 in the closed traverse. If there is no any missing quantities, we have to find out by using these two conditions, or these two we are using this formula. For example, suppose you already know that latitude formula is L cos theta and departure formula is L sin theta. Okay, so here if in the problem they have given the length of the line and directions of that line, that is L and theta. So you require the latitude of that line, you can use it directly. L is equal to small l cos theta. Similarly, for departure you can use the L sin theta. But in the some cases, if they have given the latitude value and departure value, they are not given any length of the line and bearing of that line, so they will directly give the latitude value and departure value. Then we have to find out what is the directions of that line, that is theta. In that condition, we can use the formula tan theta is equal to d by L. Okay, by simply applying the trigonometrical relations. Similarly, if they are given the latitude, they are given the directions of that line. In that condition, we have to find out the length of the line by using a simplification of this formula. We will get the L is equal to capital L divided by cos theta. 1 by cos means what? It is sec theta. We can write small l is equal to capital L into sec theta. Similarly, for departure, if they have given the departure, then they are given the direction of that line. In that condition, again we require the length of that line. Then in that condition, L is equal to d into cosec theta. After simplifying the 1 by sin. Similarly, some of the formulas are there. If they are given the L, they are found out in the theta, we can use the directly formula like that. Okay. Similarly, only length, you can use this formula also same. Okay. Instead of using the tan theta here, you can find out in the length of the line, you can use the square root of L square plus D square. Okay, these are the simple formulas are there. Okay. So for here, there are number of cases are there depending upon the missing quantities in the closed traverse. I am considering one of the simple closed towers, that is pentagon here. So this is the closed towers, that is A, B, C, D, E. So here I am written the with respect to length and theta of the bearing, that is for first line L1 theta 1, L2 theta 2, similarly like that L2, L3 theta 3, L4 theta 4 and L5 theta 5. Okay, see here all the theta 1 to theta 5, these are the bearings up to that line, and length of the with respect to A, B, B, C, C, D are represented as a L1, L2, L3, L like that. Okay. So for the first case, in case first case what it is, if L1 is missing quantity, that is they are not measured in the field, but length of the line is B is missing. Okay, but we know the theta 1 value. Okay, only length is missing. Then with respect to that line, that is AB line, theta 1 is measured in the field. So in that condition, you can directly use the summation of L, latitude, that is equal to 0. Summation of L means what? That is formula L1 cos theta 1, L2 cos theta 2, L3 cos theta 3, L4 cos theta 4, L5 cos theta 5 is equal to 0. So here I am considering the 5 sides because I am considering this is my reference diagram. If it is 4 sides are there, you can consider only 4 up to L4 cos theta 4. Simplify this one. In this case, we are finding this L1 here, remaining whatever theta 1 to L2 theta 2 up to L5 theta 5, we know the with respect to data. So just add this one, all the values. We can make it as this one as a summation of L dash. The whatever the value of the adding up to these 4 latitudes will be making the summation of L dash. Simplify this one, we will get the L1 is equal to minus of summation of L dash divided by cos of theta 1. Clear? Don't consider the minus sign. Okay, it will give the with respect to presence of the line in the with respect to quadrant. Next, second case. Similarly, we can use for the finding of the L1, we can use the summation of D also. Okay, so for example, I am taking only latitude here. Similarly, case 2, if theta 1 is missing, means the bearing of the line AB is missing. So here I am using the, instead of latitude, I am using the departure years. You can use any one, but here I am using the departure year. Summation of D is equal to 0. Summation of D means what? Adding all the L1 sin theta 1 plus L2 sin theta 2 up to L5 sin theta 5 is equal to 0. Again same, for these we know all the data here in this equations. So you can write it is summation of D dash, that is equal to 0. Then we have to find out the theta 1 here. So I am taking the sin theta 1 here only, that is equal to minus of summation of D dash. So take this L1 term this side and sin 2 this side. So theta 1 is equal to sin inverse of, in the bracket of, minus summation of D dash divided by L1. Okay, this is our simplest formula. Don't remember the formula, you can use this simplest formula here. You can write easily by simplifying this one, you will get this equation. It is not necessary to remember this formula as well as this formula. If you remember these equations, okay, that is summation of D is equal to 0, summation of D means these equations, you can easily simplify this one, you can get the theta 1 formula or L1 formula. Next, case 3. Case 3 means what? If both length and bearing of that lines are missing, means in previous 2 cases only length is missing or theta is missing, but in this case for the AB line, for example AB line, the length of the line as well as the length bearing of that line is missing. Okay, so in that condition we can use the summation of L is equal to, writing the same as it is. Let's simplify this one. we will get the L1 cos theta 1, because here L1 is also missing, theta 1 is also missing. So directly you can write minus sign of summation of L dash. Similarly, summation of D is equal to, again you can write L1 sin theta 1 is equal to minus sign of summation of D dash. The equation of these two, equating that one, then dividing the equation 2 by the equation 1, then we will get the, you can write that L1 sin theta 1 divided by L1 cos theta 1, that is equal to summation of D dash divided by summation of L dash. Simplify this one, L1 and L1 get cancelled. Sin theta 1 by sin theta cos theta 1, it is that you can write that one, that is tan theta 1, that is equal to, write it as the same as it is, summation of D dash divided by summation of L dash. Simplify this one, we will get the theta 1 is equal to tan inverse of summation of D dash divided by summation of L dash. If you get the theta 1, then you can use theta 1 in any these two equation 1 or equation 2, fill up the all the with respective values, that is theta 1 and summation of D dash or summation of L dash, we will get the length of the first line, that is L1. Okay, you can use any equation. Next we will solve the some problem on these omitted measurements. So first one is very simple here. In a traverse, the latitude and departures of the sides were calculated. It was observed that summation of latitude, that is summation of L, is equal to 1.39 and summation of departure it is minus 2.17. Calculate the length and bearing of a closing error. Okay, so here summation of L is there, summation of D is there. So closing error, what is the formula? Summation small e is equal to summation of square root of summation of L square plus summation of D square. Put up the with respect to value, that is square root of 1.39 square plus into bracket of minus 2.17 whole square. Simplify this one, we will get the closing error is E is equal to 2.577 meter. The unit of the closing error is meter. Similarly, by using this one, we can calculate theta value, that is tan inverse of summation of D divided by summation of L. Tan inverse of it is summation of D is 2.17 divided by 1.39. Simplify this one, we will get the bearing of that line, that is 57 degree 21 minutes. So here the latitude is positive and departure is negative. It means what? It is present in the fourth quadrant. Hence, bearing of a closing error is N 57 degree 21 minutes west. Okay. Next problem. It is very simplest and difficult problem for finding of the latitude and departure. A man travels from a point A due towards to the west side. Okay, west side, and reaches a point B. The distance between the points A and B is 139.6 meters. Calculate the latitude and departure of the line AB. So here I am drawing here. There is a one man is there, that is A at a point A. He is moving west side of the that point. So suppose this is here, I am considering this is your north, west side means this side. So here they have mentioned that which side it is, due towards the west, means due towards the west means he is moving exactly towards the west side only. Okay, means along the perpendicular to the with respect to north directions. The distance of the A and B is 139.6 meters. So our theta value is 90 degree. So you can usually calculate the latitude and departure of the that AB line, that is by using a L cos theta and L sin theta. So here latitude of the line AB is equal to L cos theta. Put up the with respective value, that is 139.6 into cos 90 degree that is equal to 0, okay, because there is no latitude value, because he is moving along the west side, there is no vertical distances. So latitude is 0 and departure is minus L sin theta. Here you can consider the minus sign because it is maybe present in the third quadrant or fourth quadrant. In the both direct quadrant, the departure value is negative, so I am considering the minus sign. Put up with respect to value, we will get the length of the line, the departure of that AB line, it is equal to minus 139.6 meters. And last problem I am solving on the third case, that is missing of the length and bearing of the same line. So here the length and bearings of a traverse of ABCD are as follows. So line, they have given the line length WCB, bearings in the form of whole circle bearing. We can write quadrantal bearing also. Compute the length and bearing of a line AD. Okay, so they have measured all the lengths of the line, that is AB, BC, CD, and bearing up to with respect to lines, but missing quantities length of the AD line as well as bearing of the AD line. Okay, so it is very simple. First step, solution for this problem. First step, summation of L is equal to 0. Put up all the values. Here L1 is 470, theta 1 is 336 degree 20 minutes. Okay, here instead of writing, I am written here in the form of the quadrantal bearing. Okay, so theta is, you can write directly whole circle bearing also. So for your reference, I am writing the quadrantal bearing. Why I am writing, I will tell you later. So 470 into cos of 23 degree 40 minutes plus 1780, that is L2 cos theta 2, like this. Then here I am mentioning the minus sign. Okay, here I am mentioning the minus sign because this is latitude, the whatever this theta is there, that is 39 degree 24 minutes, this one, it is lies in the second quadrant. In the second quadrant, the latitude value is negative, so that's why I am using the negative sign here. Okay, because I am using the theta in terms of quadrantal bearing. If you are using the theta in terms of whole circle bearing, you can directly use the plus sign only. In your calculator directly it will calculate the with respect to sign conventions. Okay, it is not necessary to consider the with respect to sign conventions. Okay, similar last one, this is the missing quantities, write it as L4 and cos theta 4, that is equal to 0. Similarly, simplify this one. So simplify these all the first three values, we will get the 1312.55. Take this term to this side, we will get the L4 cos theta 4 is equal to, if it is this value is taken with this side, right side, we will get the minus sign of 1312.55. That is equation number 1. Similarly, summation of D is equal to 0. Again here L1 sin theta 1, L2 sin theta 2 plus L3 sin theta 3 plus L4 sin theta 4, that is equal to 0. Because here only 4 sides are there, that's why I am considering the 4 equations here, or departures. So here by observing the theta 1, it is lies in the third quadrant, so that's why I am returning here, because theta is present in the here, sorry, it is fourth quadrant. Okay, northwest. In the northwest it is departure is negative, so that's why I am using the sign convention negative here, minus 470 into sin 23 degree 40 minutes plus 1780 sin 15 degree 20 minutes plus 1080 sin of angle 39 degree 24 minutes. plus L4 sin theta 4 is equal to 0. Simplify this one, we will get the L4 sin theta 4 is equal to minus 967.54. Simplify this one, we will get the like this, that is you can take these two terms will be summation of d dash and summation of L dash like that. So therefore L4 is equal to square root of summation of d square plus summation of L square. Here I am written the summation of d dash is this one and summation of L dash is this one. Okay, put up the respective values with respect to sign convention also. So simplify this one, we will get the 1630.61 meters. If you know the length of the line, then we can use this tan theta or tan theta equal to summation of d dash divided by summation of L dash, that is theta 4 here. Put up the with respect to values. Okay, then we will get the theta 4 is equal to tan inverse of summation of d dash divided by summation of L dash, that is equal to tan inverse of into bracket of minus 967.54 divided by minus 1312.55. Simplify this one, we will get the 36 degree 23 minutes. So this is plus sign. By observing this one, we will get the bearing of the DA is in terms of south 36 degree 23 minutes west side. This is the one of the method here. Instead of this one, we can use by using a tabular form like this. Okay, these are the line. Here missing is AD line. Just remove that one. Remaining whatever we know the length and bearing of the with respect to line right here, and with respect to positive and negative latitude values are written here like this after calculating the latitude and departure with respect to sign convention, making the two columns plus and sign minus sign. Just add all the values with respect to columns positive and negative in departure and latitude. The difference of these two will get this one. So the difference of this one and this one, we get the summation of d dash is equal to plus 970.54. So now here that is summation of L dash. For here I am writing the same condition here. Latitude of dA is equal to, you have to consider the opposite sign convention here. If it is here positive, you have to consider the minus sign. If we are getting the here it is minus sign, here we have to consider the positive. You can write it as a positive summation of L dash. So in this case, in the after difference of this positive and negative latitude and positive departure and negative departure, we are getting the both are positive. So here I am writing the summation of L dash with respect to minus sign, summation of D dash with respect to minus sign. Put up all the values, we will get this like this. So by using this formula, we are getting the theta is equal to 36 degree 28 minutes. Put up this theta value any equations, we will get the length of the line dA is equal to summation of dl divided by cos of 36 degree 28 minutes. Simplify this one, we will get the same length. Okay, this is the one of the example. One more example here. Here they have given the 5 sides. So they have missing quantities EA. So you have to practice this one. Thank you.